All right, so I'm going to do some problems that usually give y'all issues. So on this one, I'm going to find the domain of the function. And they're giving me g of x equals 10 divided by 10 minus 7x. All right, so remember on the domain of a function, we're worried about fractions and radicals. So we do have a fraction, so we're worried about the domain on this. So to solve this, I took the bottom and I set the 10 minus 7x equal to 0. And we're only worried about the denominator on this, remember. So solve this. I'm going to subtract 10 from each side. I get negative 7x equals a negative 10. And then we divide both sides by negative 7. So that x equals, so negative divided by negative is going to make that a positive. So that's just going to be a positive 10 over 7. Now the answer would be x such that x is a real number and x is not equal to a 10 over 7. Okay, so just remember, domain only worried about the fractions and the radicals. All right, here we go. We're going to let f of x equal negative 5x plus 2. G of x is going to equal x squared minus 5. They want us to find g minus f of x. So you're subtracting functions. So I'm going to start out. I'm going to do my g minus my f. Now, subtraction, you definitely want to start out using parentheses. All right, my g equation's first, which is x squared minus 5. My f equation was a negative 5x plus 2. So basically on this problem, you're going to add like terms, but you got to get rid of the parentheses first. So there's nothing in front of the first parentheses, so that comes out as an x squared minus 5. Second parentheses, since they follow subtraction, we need to distribute our subtraction through the parentheses. So when you subtract a negative 5x, that's going to become a positive 5x. And then distribute the negative through to the 2, and that'll make that a minus 2. At this point, add like terms. So bring down your x squared. Then I'm going to bring down my 5x. And my like terms will be the negative 5 and negative 2, which give us a negative 7. Okay, so just remember subtraction started out in parentheses. Are y'all good so far? All right, this next one's a pretty tough one. They're giving me f of x equals 1 divided by x minus 7. G of x is going to equal 10x to the third. They want to know the domain of the sum, difference, and product of the two functions. Okay, so let me start out with the sum. So f plus g of x. So if I was going to take these and add them, f of x would be 1 over x minus 7, adding that to a 10x to the third. So on this one, I got a fraction in the first function. So on that one, I got to see if there's any numbers that'll make that undefined. So I'm going to take that x minus 7 and set it equal to 0. All right, so let's see. On this one, we would what? Add 7. And I get x is a positive 7. There's no restrictions on the 10x to the third. So the only number I got to kick from my domain is 7. And let's see. So this one would be x such that x is a real number and x cannot equal positive 7. So then they said the difference. Well, the difference would be f minus g of x. That'd be my f equation, 1 over x minus 7, minus my g equation of 10x to the third. So we're subtracting, but the only part I'm worried about is the one with the fraction again. So once again, we would set that denominator equal to 0 and solve it, which means I'm going to actually get the same number, 7, so that this is x such that x is a real number and x cannot equal 7. You'll notice that adding, subtracting, and multiplying usually have the same domains on these. So the product, f times g, would be the 1 over x minus 7 times the 10x to the third. Once again, I've only got the one fraction I'm worried about, so we would set that denominator equal to 0 again and solve it, and we would get 7 again. So that means that this domain is going to be x such that x is real number and x is not equal to 7. Okay, y'all, so just watch out on those. All right, y'all, here I got f of x is going to equal 7x minus 8. G of x will equal 8x minus 32. I'm going to determine the domain. So the domain of f divided by g. All right, so f divided by g would equal the f equation, 7x minus 8, divided by the g equation, which is 8x minus 32. So remember, once again, I'm only worried about the denominator since I got a fraction. So I'm going to take the 8x minus 32, set that equal to 0, and solve this. So on this one, y'all, I'm going to add 32 to both sides. And then divide both sides by 8. So that I get x is a positive 4. So my domain will be x such that x is a real number and x cannot equal a positive 4. All right, y'all good on these so far? All right, so I'm gonna get into some of these compositions.
Yes, thank you.
Let's see on this one. They're giving me f of x equals 2x plus 1. Let me pull that up again. All right, y'all, and g of x is going to equal x to the third. They want me to find f of g of a negative 1. Now remember, this is the compositions. This is where we're going to put one function into the other. So they're giving me a negative 1 actually to put into this one. So remember, this is like doing a f of g of negative 1. We're going to take that negative 1, put it into the g equation. Once I get that answer, I'm going to put it into the f equation. So first, we're going to find g of negative 1, which we're going to take the g equation and replace that x with a negative 1 to the third power. All right, so negative 1 times negative 1 is 1. 1 times negative 1 is negative 1. So this gives us a negative 1, which means now, since g of negative 1 gave me negative 1, I'm going to put the negative 1 into the f equation. So now we're going to find f of a negative 1. So take the f equation, 2 times x, which is a negative 1, plus 1. All right, so let's see. Multiplying 2 times negative 1 gives me a negative 2, plus a positive 1, which gives me a negative 1. Now, y'all remember, mine only done that because I was playing with ones on this. Any other number, it wouldn't actually end up being the same as what I started with, okay? All right, I got f of x equals 6 divided by x plus 2. They want to know, is it 1 to 1? And if it is 1 to 1, find the inverse. Okay, so these are definitely all going to be 1 to 1. But if you want to check, go to your graph and just punch in 6 divided by parentheses x plus 2. On that calculator, when you got fractions, you want to put them in parentheses if you got more than one part on top or bottom. Okay, so let me graph it just to show y'all that it's definitely 1 to 1, because I can do that horizontal line test to it. Okay, so it's 1 to 1, so we're going to find the inverse. So the first thing to do to find the inverse is replace the f of x with a y. So we get y equals 6 divided by x plus 2. Then I switched the x and y around so that I get x equals 6 over y plus 2. Yeah.
When will you have a break?
11, 15 or so. Why?
Okay, they need to change our meters and they'll turn the electricity on.
Oh, okay. Oh, did I got to do it now?
No, he said he could wait a little bit.
Okay, see if he can wait about 30 more minutes.
Okay.
Righty, y'all. So I switched my X and Y around. That's someone here trying to change my electric meters out or something from these storms, I guess. All right, y'all. We're going to solve this for the Y. So I'm going to treat this like a 1 under my X. And the easiest way to start out on this is what I do called cross multiplying. So I'm going to take this top X and multiply by that bottom to Y plus 2. So I cross multiply that way. Now I multiply to 1 times 6 on the underside and get a 6. Now, I'm not going to distribute my X through here. What I'm going to do is divide both sides by the X so that I can get the Y plus 2 equal to a 6 divided by X. So basically, all I did was flip-flop that Y with the X plus 2. Okay? Now we're still solving this for the Y. So at this point, to get the Y by itself, I would subtract 2 from both sides. So that's going to give me Y equals 6 divided by X minus 2. So now we have it solved for the Y. The last step would be to replace the Y with the F inverse notation, which the answer blank will give you this part. All you got to put in is your 6 divided by X minus 2. And that would be the inverse of our equation. Okay, so the trick is just replacing it with the Y, switching them, and then solving it for the new Y, okay? All right, let me pull this up again. All right, so on this one, I've got a 3x plus 2y is going to equal 34. And then I got 2x plus 3y equals 36. So solve by elimination, it'll say, but this is where we were solving the systems of equations. So on this problem, you got to determine whether you want to get rid of the x's or the y's. And y'all, they both look the same to me. So I'll get rid of the y's, then I can solve it for the x's. But I got a 2y and a 3y. So to eliminate one of them, one's got to be negative, one's got to be positive, and they got to both have the same number in front. So the smallest number that I could turn a 2 and a 3 into would be a 6. So I'm going to take my second row, multiply by a negative 2 to make that a negative 6. I'm going to take my top row and multiply by 3 so that gives me a positive 6y. Okay? So everybody gets multiplied by 3 on top. So I got 9x plus 6y will equal, let's see, 34 times 3 is 102. Second row, multiply everybody by negative 2. So all these positive numbers are going to become negative. So I get a negative 4x minus 6y equals a negative 72. But notice my y's are canceled. So I got 9x's minus 4x's leaves me 5x's equal to 102 minus 72 is 30. And then the last step, divide by 5. So that x equals 6. Now that I know x equals 6, I can plug it into one of my two equations and solve for the y. So I'll just use that first one. I got 3x, which will be 6, plus 2 times y equals 34. So 3 times 6 is 18, plus 2y equals 34. All right, what's next? Subtract 18. 2y equals, what's that, 16? And y'all finally divide by 2 so that y equals 8. So your answer would be an ordered pair of 6 for the x and 8 for the y. And then if you wanted to, you could plug these into either one of your equations and make sure you get a true statement, okay? So like right here, 2 times 6 would be 12, 3 times 8 is 24, 12 plus 24 equals 36. All right, I'm probably gonna need another piece of paper for this next one, so let me move this one over. All right, y'all, 9x minus y plus z equals 18. 3x plus 2y minus 3z is going to equal negative 21. And then x minus 3y plus 2z is going to equal 22. All right, so on this one, I'll do it by hand, but remember, you got programs you can use for this one. So 3 variables. Let me move that up where I can see that better. So I got to determine which variable I'm going to get rid of first, and then I'll do that a second time, and then I'll finally get to my answer, and then I'll start doing all my back substituting. So y'all, I'm looking at this. To me, the y's or the z's are probably the easiest. So I think I'm going to eliminate the z's first. So this is where I said equation 1, equation 2, and equation 3. So first thing I'm going to do is add row 1 and 2, but I'm going to multiply row 1 by 3 so that I get a 3z. That'll cancel with my negative 3z. So I'm going to multiply 1 by 3 and add to 2. Okay, so if I multiply this row by 3, I get 27x minus 3y plus 3z will equal 18 times 3 is 54. And then I got 3x plus 2y minus 3z equals negative 21. When I finish this, I'll have a row 4. All right, so let's see what we get. 27 and 3 give us 30x. Negative 3 and 2 give me a negative 1y. The z's cancel. And 54 minus 21 is what, a 33. So that's equation 4. Now to find equation 5, we've got to use row 3 with any of the other 2 rows. So what I'm going to do is take row 3, which has a 2z, and add that to row 1, which has a z. But since this one has a positive 2z, I'm going to multiply row 1 by negative 2. So I'm going to multiply 1 by negative 2 and add to row 3. All right, so that would give you a negative 18x plus 2y minus 2z would equal a negative 36. So all the signs got to change when you divide by negative. All right, now bring down row 3, which was a x minus 3y plus 2z equal 22. All right, when we add them, we'll have our row 5. All right, so let's see. Negative 18 and 1 give me negative 17x. 2y and a negative 3y give me a negative y. The z's cancel. And a negative 36 and a positive 22 would give me a negative 14. All right, so let's bring them over. 30x minus y equals 33. This one was a negative 17x minus y equal negative 14. So that's your row 4 and 5. So now it looks like the easiest thing to eliminate would be the y. So I'm going to eliminate the y. Now, I'm going to multiply the second row by negative 1, so that'll make that a positive y. That'll cancel with that negative y. So I'm going to bring down the first row. 30x minus y equals 33. Now, multiplying by negative 1, all that's doing is changing all three of these signs to a 17x plus a y equals 14. All right, y'all, so let's see what happens here. 30 plus 17 is 47 x's. The y's cancel. 33 plus 14 is 47. So the last step, divide by 47, so that x equals a positive 1. Now that I know what the x is, I can back substitute this, find my y, and then once I got the x and the y, I'm going to go back into the first equations, okay? So here we're going to back substitute. So I can pick either one of the equations from 4 and 5. So I'm just going to do this one. 30 times x, which is 1, minus y equals 33. So that's going to give you 30 minus y equals 33. So let me subtract 30. So negative y equals a positive 3. Remember, I need to make the y positive by dividing by negative 1, so that I get my y equals negative 3. So x is 1, y is negative 3. I'm going to plug back into my first equation and solve for the z. So I got 9 times x, which is 1, minus y, which is a negative 3. So be careful there. That's going to end up being positive since I'm subtracting a negative. All right, plus z is going to equal 18. All right, so that's what? 9 plus 3 plus z equals 18. 9 plus 3 is 12. Plus z equals 18. Last step, subtract your 12. And z looks like it's going to be a positive 6. Now remember, this has to be put in the form of a ordered triple. So the x is first, which is a 1. Then the y, which was a negative 3. And then the z, which is a positive 6. And y'all just remember, I gave y'all a program knocking these out, or you can use the matrices I sent on the video for y'all, okay? All right, y'all got any questions on these yet? So good to go still. All right, so let me try one of these graphs, and I got 4x minus 3y is less than or equal to a negative 9. And this one says graph the inequality. So this is where you had to do some little bit of shading. So easiest way to solve these to me is to solve these for the y. Okay, so I'm going to solve this for the y. So I'm going to start out by subtracting 4x from both sides. If I subtract 4x, that'll give me negative 3y is less than or equal to negative 4x minus 9. Now, order don't matter on that right side, but I usually put my x's before I do my numbers, okay? Now, we need to make that negative 3y a positive 1y, so we're going to divide by negative 3, and everybody gets divided by that negative 3. But y'all, here's the thing. Since I'm dividing an inequality by a negative number, my less than or equal will now become a greater than or equal. And then negative 3 divided by negative 3 makes that a positive 1y. Negative 4 divided by negative 3, I'm just going to make that a positive 4/3 x. And then that negative 9 divided by negative 3 would make that a positive 3. All right, so I'm doing this one by hand, so let me draw me a little graph here. X and my y. So let's see. I'm going to use a 0 for one number because I always use a 0. And since this one's a fraction, I'm going to use a 3 for my second x. All right, so let's see what happens. We put a 0 in. 0 times 4/3 is 0. 0 plus 3 would be 3. But remember, that's your y-intercept, so it's got to be 3 when x is 0, okay? Now, this time I'm going to put a 3 in. And I'll actually show you what I'm doing here. I use 3 because the 3's will cancel, turn it into a 1. And 4 times 1 will be 4 plus that 3, so that y is greater than or equal to 7. So when my x is 3, my y is 7. So let's go 1, 2, 3, 4, 5, 6, 7 that way. 7 that way. 7 there. And there. So that's my biggest number. So here you go. You got 0, 3. So 0 on the x's, go up 3 on the y. Then I got 3, 7. So right 3, up 7. So now I had to figure out, is it solid or dotted? Well, since I got equals under that, it's going to be a solid line. And then since it is greater than, remember, you got to go to the actual equation you're using, and it's greater than, and greater than will shade above the line. So let me show you how I'll do that on my calculator. You got to solve it no matter what you do. So I ended up with a 4/3 x plus 3. So that'll be 4 divided by 3x. Or, let me show you another thing you could have done. You could have said alpha y and enter on that, and that'll let me put a 4 on top and a 3 on bottom. And then I got my x, and then plus 3. So I got my equation. Now I want to shade it. Remember, I had the arrow all the way left on the left side of that y1 until that line was blinking, and then hit enter until I get a triangle that's above. So there's my triangle above. So now I got everything like I wanted. I'm going to hit graph and see if it looks like what we got. And y'all, that looks pretty nice to me. So there you go. All right, this one you couldn't graph. X is less than negative 1. All right, so let me graph this. Now, anytime you get one variable like this, an x, and just one number on the right side, that means no matter what, these x's got to equal -1. Now, it don't matter what you use for the y values, so I'm just going to pick a 0 and a 1. The y's can be any number. The x has to be -1 in this situation. Okay? So, there's 5. All right, so what you do when you got x less than -1, you go to the x-axis and find -1, which is right there. Then you're going to go up or down. So there's my -1, 0, -1, 1. But you can use any y values you want as long as that x is always on that -1 there, okay? Now, there's no equals on this, so this would be a dotted line. And on the x-axis, less than shades to the left. If that had been greater than, I would have shaded everything to the right. So, now, remember the x's are vertical lines like this. If that would have been a y, it would have been a horizontal line, okay? All right, let's see. We're going to graph the system of inequalities. So y is greater than or equal to x plus 5. Y is less than or equal to 3 minus x. So the trick on this, to solve a system of inequalities, we're looking for the region that has double shading. Okay, it's got to be double shaded to be the answer for both of these. So basically, you would set up 2 tables to solve both of these, okay? So both of these, there's no fractions. So both of my x's will be 0s and 1 for both equations, okay? All right, let's put a 0 in. 0 plus 5 is 5. I put a 1 in. 1 plus 5 is 6. Now the second line, I put a 0 in. 3 minus 0 is 3. I put a 1 in. 3 minus 1 is 2. So I got my 2 lines. So let me make some points here. All right, y'all. So line 1, I got a point 0.5, which is on the y-axis. And then I got a point over 1, up 6. So both of these will be solid lines because they got equals. So this line's going to come down through here. Now the first line is greater than, so the first line is going to shade above. So I'm shading above that line, okay? Now let's plot the second line. I got a 0, 3, so starting at 0, go up 3. And then I got a 1, 2, so go right 1, up 2. So that line is coming down. It's less than, so it's going to shade below. And if you notice, the double shaded area is this little area on my left side here. So the only answer would be the picture that has that one shaded region. And I'm going to show y'all what you're looking at. So here's their answers. They only highlight the double shaded regions. So on that, we went with D because ours was on that left side, okay? right, let's see. All right, so I'm going to do y equals absolute value x minus 6. And I'm doing this one because I just want to refresh you on graphing this one. MATLAB is picky on this one. So this is absolute value. So the tool you're going to use will be the absolute value tool. And I think it's got 2 dots on it, which means you need at least 2 points. The trick on this one is to make the middle x value, whatever makes that equal 0 inside of that. So the way to get a 0 in there would be if that x was a 6. So my middle number would be a 6, and I'll just make this a 5, and that and a 7. The middle number, which is going to be this little vertex point we call it, has to be whatever number makes that equal 0 inside them bars. All right, so let's find these y values. If I put a 5 in there, 5 minus 6 is -1. Absolute value of a -1 is a +1. If I put my 6 in, 6 minus 6 is 0. Absolute value of 0 is 0. If I put the 7 in, 7 minus 6 is 1. Absolute value of 1 is 1. So you'll sort of see symmetry. You got that vertex point, and then on each side will be the same numbers, and you'll notice that going all the way through there, okay? So on MATLAB, you gotta plot the point 6, 0 first. So there's 5, 10 that way, 5, I'll go about 7 that way. So I come over here, 6, 0, put my point. And then on MATLAB, you can use either one of these other points, and it'll draw it for you. So I can come over here to 7, 1 and plot that one. When you plot that second point, it's going to draw the V graph for you, okay? Or you could have plotted this side, 5, 1. It don't matter which side you draw. On your calculator, absolute value, hit the math, arrow right to number, and the first thing you see is ABS, which is absolute value, and then put in your x minus 6. So it looks like the equation. I'm going to hit graph just to show you. There it is. But if you wanted numbers, just hit second graph and bring up your table. But remember, you want to arrow down until you start seeing that symmetry. So there's the 0, and then there you go, 1, 2, 3. It'll start being symmetric on each side of that 0, okay? All right, let me see what else. Y'all, let me do one more for you. And this one is a y equals x squared plus 3. So the same thing on this one, I want an x and a y. Now, on this one, you can go to graph and then do your x squared plus 3, and then hit the graph, because this is going to be a parabola, right? And we know that the center of this is going to be when the x is 0. So that's going to be my middle number. And then I'm just going to use a -1 and a +1. So on your x squared graph, you want 0 to be the middle number. All right, so let's get the y values. And remember, this will be symmetric also. So you put a -1 in. -1 squared is 1. 1 plus 3 is 4. You put a 0 in. 0 squared is 0. Plus 3 is 3. Then you put a 1 in. 1 squared is 1. Plus 3 is 4. So notice how it's getting symmetric. Now remember on this one, you gotta start with that vertex point again, or that minimum or maximum point, okay? So the first point you have to do is 0, 3. So 0, you would go up 3. That's got to be the first point you plot. And you're going to use what we call the quadratic tool that has 3 dots on it. So you start here, and then you're going to do a dot on each side. So here's 1, 4. At that point, it's still got a straight line, but when you come to this side and do -1, 4, it's going to curve and make you a parabola. Okay, I just wanted to bring back memories. When you're using absolute value and the quadratic tool, you got to start with these vertex points on that math lab, okay? And then once again on this one, I could have went to my table. And let me go up where that 0 is. So there's the 0, and then you'll notice on both sides it starts getting that symmetry, okay? Alrighty, y'all, so here's the thing. Those are probably the hardest questions on there that y'all haven't seen in a while. So this test will be open till Sunday, so I had to redo my due dates. So it's open till Sunday. Remember, do your review as many times as you want to, okay? In order to get good on that. And then once you get good on that, then you can start knocking out your actual test. All right, so y'all hang on just a second. I'm trying to get some names on here real quick. All right, I think I got everybody, so I'll stop recording that.